When performing the glucose assay using adenosine as the chromogen, we notice that the colour change induced by the presence of glucose is reversible. For that reason, you need to add the sulfuric acid to stabilise the colour change immediately after vortexing the samples. This video demonstrates the colour change so you can see the time frame over which the problem occurs. Here we see the reacted glucose standards from the original version of the assay. In this version we went from 0 millimoles of glucose up to 20 millimoles of glucose for the standards. You can see that as a result of the colour change reversal problem that we're describing here, the more concentrated glucose standards become a lighter colour than the less concentrated glucose standards. This nonlinear colour change is a problem for determining the concentration of glucose in this assay, so therefore we need to fix the problem. As a reminder, in the standards tubes you can see that we add 0.14 ml of glucose standard, 0.28 ml of assay reagent, and then after the reaction we add 0.28 ml of 12 normal sulfuric acid to stop the reaction and to stabilise the colour change. To demonstrate what this looks like, here we add the 0.14 ml of the glucose standard. Next, we add 0.28 ml of the glucose assay reagent, and then incubate the samples on a heating block for 30 minutes at 37 degrees Celsius. After incubation, we see a pronounced colour change in the glucose standards. You'll notice that in the lower concentration standards, the colour change will be uniform. In the higher concentration samples, however, the colour change only seems to occur at the air-liquid interface, probably indicating some sort of oxygen dependence. If you vortex the sample quickly, the colour change will develop throughout the rest of the liquid and you will end up with a sample in which the colour change is uniform, which is what we're after. If you leave the sample standing, however, the colour change will then reverse. In this example, we have sped the film up for the sake of time, but the full colour change reversal took only 36 seconds in real life. So, what you will need to do then when running this assay is, once your samples have incubated on the heat block, you will need to vortex your samples, then immediately add the sulfuric acid, being sure to titrate the acid up and down in order to mix it completely and stabilise the colour change. You should notice that the brown adenosine reaction product turns purple when you add the sulfuric acid. Once this is done, the colour change is stable and will no longer reverse. So by following these suggestions for both the glucose standards as well as your food test samples, you will obtain the most accurate glucose measurements using this assay.